Hello and welcome back to another episode of Gifting at Oxide, a brand new show. Welcome back, Sydney.
Hi, Sebastian.
Yeah, Sid, can you tell us what the gift is that we're talking about today?
A gift. Well, let's see about that. But yeah, finally getting into some actual Git oxide from my side.
Yeah.
My first pull request, my first little contribution. I mean, not yet, but yeah, we're about to take a look on into what I produced there, and yeah, see how it looks.
The Pathspecs. So that's what this is all about. What's a Pathspec? Like real for like git add foo. Is this a Pathspec?
This is a path spec, yeah. Technically, it looks like a path, and you can have all sorts of tiny little features in there, like globs, for example, it supports, but also these little directives at the beginning of the path, basically, that, well, activate certain modes for how the paths are calculated, basically.
And how do you do this? Like, I feel like I want to definitely quote this with single quotes.
Yes, you need to quote it. Then you start with a semicolon, and then, sorry, with a colon. And then, for example, so you always put this in parentheses, not the angle brackets, sorry, not the square brackets, but the actual parentheses.
Like
sorry,
this.
Again, colon, then parentheses. And then inside you can have certain directives, like for example, top. And that always ensures to search from the base directory, from the base Git directory. Or you have something like exclude, which means that you exclude the actual path that is behind it. And yeah, there's some, I think 6 magic words, as they call them, or magic signatures. And yeah.
So I could say foo hello like this, but I want to exclude. Is this a colon here again, or?
Yep, you can, but it's optional.
Okay. Or I want to say, I want to exclude helli. So everything hello I get, but helli I don't get.
Exactly.
Something like that. Okay, that's cool.
Yeah, and you can have multiple magic words in parentheses, like comma separated. And for certain ones, for example, exclude would also work as a colon and then exclamation mark. So as a short form, basically. And you can combine these in all sorts of ways. And this is, yeah, sometimes can get a bit confusing because I'm not entirely sure yet how Git handles these weird combinations, because it technically never throws, but I think sometimes it doesn't give you the expected output as well. So it's a bit unclear how Git handles these.
I see. So what is a hard error and what is just a pattern that is actually a path because it doesn't parse as a pattern, and then it's just a weird path that nobody ever has. And what?
Something like that.
Yes. And yeah, that's definitely an interesting conversation to have at some point. Like, what should Git Oxide do? Be more lenient, less lenient, or have a strict mode where it really tries to, reject stuff that looks like a pattern but actually isn't, and Git would just go with it and match nothing, and Git Oxide could possibly say something else. Yeah, I don't know either. It's just ideas. I guess as a baseline, we should not reject something that Git does not reject by
Exactly.
default.
So the only error I found with Git is, I think, if you have a space in this comma separated list, so it doesn't like spaces in there, but the rest it pretty much just parses somehow.
All right. It reminds me a bit of globs, by the way. Like, same thing. It is very lenient. It just parses stuff. There's basically no way to hard error that. Or maybe there is, but I forgot about it, so it's not really obvious what happens there. And yeah, it's just a path. If it's not a glob, it's taking this path, which kind of makes sense, I guess.
Yeah.
And Pathspecs go into the same direction. Okay, so thanks a lot for the introduction. I learned something. Also, I think many people, they don't have any idea that they have the power of Pathspecs when they enter some path. And most people won't see this as pathspec here because the shell will do its magic and then it will just be simple path. So yeah, if you're not a kernel developer, chances are you didn't use that yet. Or if you're not a Git developer or somebody really deep into that matter.
Exactly.
Yeah. It's, fun fact, like the documentation is quite sparse, as there's one good blog post and there's the glossary. So in the glossary, you have the specification for a feature that is used in many different commands, and it's a big specification at that. Like, it's so sidelined by Git itself that you wonder, like, who is actually using this, who finds this important. But then again, inside of the Git code base, you always have to deal with this, and you actually, from experience as an application developer, you definitely want to support it somehow, or some people want to use that. Especially, by the way, if you're an application developer, like for Git Oxide, like if you have a shell, simple glob patterns, they usually do the trick according to what people expect. But from an application standpoint, then you don't have that. But Pathspecs, they kind of re-add the glob-based matching that the shell does. So you get that capability for free. And that's what people or application developers definitely want. You kind of need that. So from Git Python, I know people expect to have it, but Git Python doesn't have it because I never thought it was necessary.
I mean, there are some useful things in there, definitely, but like you said, it's pretty hidden.
Yeah.
So you have to know about it, have to find out somehow.
Actually, I have to revise this, revoke this last statement. Git Python has a pathspecs, but it's implemented in such a naive way that it's basically not really working. Like the double asterisk, the double star stuff to search recursively, this is kind of implemented, but so it's not properly implemented. So it really is, I don't know what I was thinking. It's like ridiculous. But with the technique or technology that we already have here, I think we can, for the first time, properly implement Pathspecs for Git Oxide. And it's going to be quite some work. Right, now that we know what this is or is supposed to be, let's look at the parsing. I mean, technically, yeah, Pathspecs, it's a big topic. We can actually maybe scope this a little more so that this doesn't stay open for 5 months. When we realized that Pathspecs is so much more than we anticipated, like it's not the first time.
So not.
So parsing, then this is kind of in progress.
This is in progress, and I guess the other part would be the matching it, essentially. Just taking what is parsed and then giving you some sort of result, or at least some sort of something you can work with, basically.
Yeah, let's outscope this right away. Let's make another PR. This sounds like you have to deal with multiple pathspecs, and then you have to have them in a list and efficiently or not efficiently, at least correctly, match with that. And there's some experience with that in the Git Oxide code base already, but it's definitely something that needs some work. Okay, we can parse. Then I'd say as a requirement, the error handling is not more strict than Git, and we have proof. So I write this just because this is the, there you really have to run it against Git and see what Git says, and maybe pull some, pull as many examples as you can out of the Git test suite.
Find some good cases, basically.
Yeah, the hard ones that they added after they saw bugs or whatever, and then you have a little more safety, even though you never have perfect proof. Unless you kind of transpile C to Rust, then you kind of have proof because the same code. But of course, we wouldn't do that. Okay, parsing, error handling. Then we have a pattern that has the information baseline that Git usually has, and that can be used for pattern matching later. And that
exactly. It's a question of how how far the parser would go, because at the moment I was always looking at a single statement and that parses successfully. But as soon as you have multiple ones, is that still the job of this crate, or is that something that is happening a layer above, basically?
Multiple Pathspecs, you mean?
Yeah, exactly.
Yeah. Yeah, good question. Also because these Pathspecs, they're almost always given on the command line. But also once you have a method or some functionality in Git Oxide that would accept Pathspecs, how do you pass them so that you can still match on them? So would there be some Pathspecs, plural, type that is the pattern matching version of this? And this is kind of what everybody expects? Or is there a vector of path spec singular, but then the matching has to be kind of fiddled around with on case-by-case basis? Sounds a bit like there should be some type that can implement stuff that is related to matching, but also we're talking about matching, I think. And it sounds like parsing individual things is already good enough to build up from there. And even if we change our minds, which might well happen, I think it's okay to start with this and then have more PRs as we come along. Small PRs are good from my point of view.
That's good.
Okay, cool. So that's the initial scoping. And we are made with the code. I took the liberty already to pull that down. And we should be able to look at this. So in Git Pathspec, this was a crate that I created a bit early just to reserve the name, later realizing that maybe Git Path as a crate that also is now there is better suited to have the spec. But then I realized, well, having these small crates is actually cool because then testing is much faster and you kind of are more focused. So I think it's good to put all the Pathspec related stuff here, probably including pattern matching, and then pull this up into Git Path where there can be a spec type or specs type. And it's just convenience mainly, maybe with some added bells and whistles that the people usually use. So this is the plumbing of Pathspec with all the nitty gritty. And so I guess we will spend some time here to implement Pathspec in all its, for everything that matters. Okay.
For sure.
Now for the, sorry, say again?
For sure, I said. Yes. We will spend some time.
Now let's run the tests. And they're green, that's great. Run in 0 milliseconds, perfect. Did it actually do anything? Let's check it out in a moment. Oh. And yeah, this crate was empty, so everything we see here is something you added, and I can just, stream of consciousness, like say what I think, and you can say what you think, just have a dialogue about it. And first thing I see as a positive, somewhat surprise, is that there's a private module parse, and there's a public function parse that obtains, it uses a pattern that is pulled up from the private module here. And you see that pattern, you see that programming pattern a lot, or that pattern of organization, you see that a lot in Git Oxide. So I'm pleased to see this here too, which allows us to have a module named parse, so we have that functionality a bit more isolated and don't have to throw it all together. So I like that. What I tend to do, by the way, I mean, this now looks like a parse pattern if you see it here. So unless you see the code, this is not obvious, right? Like this looks like Git Pathspec pattern, which is a good name, I think. But here it looks like it's a parse pattern. This was my first intuition. Is it a parse? Until I realized that this is private and so on, I was thinking, is it a parse pattern that is really specific to the parser? Which could be. But it looked like it's not. It's just the output of the parser itself. And
exactly,
it's owned here. That is fine to me, totally fine, because we will always, these things, they will always be owned. And then I also say the parser should spit out something that is owned because that's usable. There's no need to have an intermediate zero copy thing, which might not even be possible depending on what transformations you do on the path. I don't know if this parser does transformations or not. You know, never mind. That's my stance on it. Don't worry about it. It's small. It's bigger fish to fry elsewhere. Easy to use is more beneficial. However, since this is not specific to the parser here, I do tend to take these things and actually pull them up so that it's obvious that this is a pathspec pattern. It has nothing to do with the parser. It's what we work with, and that's that. And that's my reason.
I thought about that as well, just because this is how you end up using it. But for some reason, like when you're in the Pathspec library, like working with it basically or developing it, it's kind of more obvious to me to find the pattern in the parse file, basically, because it's logically for me this belongs together. But in the context of the whole of GitOxide, it kind of makes sense to pull it out, to see it as something not separate, but you know, it's not private, so it doesn't have to be in there.
Yeah, I understand. It makes sense. Also makes sense. It's more like ultimately it's going to be used from the top level. This is also what the imports say, and this is why I think there's a strong case that it belongs here. If it would be a zero copy pattern that is something that the parser spits out, and then you have to make something out of it, and also that exists somewhere else in GitOxide, then it would be a parse specific thing, and then this would probably be module, a public module, and so on. So that's that. This is repeated in a lot of places in GitOxide, that you just throw these into the lib. And if there are too many of them, you have a separate private submodule that says types, and you throw them there, and then you import them up, like happened here, essentially. It's just, for now, I think it's okay to put it here. Then we have the bit flags. Yeah, I think I tend to put these modules up, but I'm never really sure, honestly. Sometimes probably I put them up, sometimes I put them down. I don't know anymore. It probably doesn't matter in the big scheme of things. But consistency is nice, but I don't get it. So it's not obvious to me. It's just pick your lane and then you drive there.
Just happens.
Yeah. So let's say we just do it here like this, but there's examples where it's done the other way around. Then the magic signature. By the way, it's great that there's no documentation. It's strange to say that.
Oh yeah, this is still planned.
No, I mean it. It's great. It's not. I try to avoid sarcasm really, because it doesn't usually translate well. It's great because you focus on what matters, and things change a lot potentially here, and you don't want to document stuff that then is being swapped around and then the documentation is out of date. So it's great. Don't force yourself to do it. And later, once the API settles, put an attribute here that forces you to do that. And then you document, and that's the last step before that thing can move from here, Pathspec. So idea now definitely moves here to very early. And then once the docs are written, it can move to usable. And from usable, eventually it can graduate to being a stabilization candidate to being stabilized. So that's kind of how I do things by now, that developed over time. Yeah. So that you actually work on that, so that you ask, does this have to be usable only? Can this be, like, did you not change it in a while? Then probably it's a candidate for stabilization and so on. And that's how I actively work on getting these 30 crates to stable one fine day. So yeah, progression. Good. Now magic signature keeps a bunch of bit flags, top literal, I case, glob, adder, exclude. I guess that's pretty much what Git uses as well, huh?
Yeah, this is what I pulled from the two examples I posted. I haven't looked at any Git code, so I can't compare it with that. But just from what I found documentation-wise, this is what's documented.
Oh yeah, interesting. From top, literal, glob, I case, exclude, adder. I see. Yeah, see, you are like what you're doing is probably a great idea because you do it, like you implement it the way it should be according to the documentation. And that is absolutely correct because the documentation is a source of truth. The code can keep some secrets that didn't make it into the documentation that are specific enough that you definitely wouldn't think of it maybe. That's why I always look at the code at some point. It's kind of a spoiler as well, because then you're kind of already having a mindset when you implement anything new.
Yeah.
It's probably good not to, to go into the cinema not knowing whether the hero is gonna die in the end.
Exactly.
Or, yeah. And so.
No, but I agree. Like I thought, just approaching this from how I think it should work also, was necessary for me to just understand what I'm actually want to write. And then at some point, it's definitely necessary to look into the code because you need to be sure that, I don't know, certain cases are handled the same way. Just need to ensure that it works the same as Git, basically.
Yes, exactly. And also, I think as an exercise, it's good to just be able to write what you think it should be. And then, you can write good Rust code and not be forced into some C style of doing things just because you've seen it and think that's the way. So I like that approach too, to just look at the C code later. Okay, so now we dive in to the big one, big in the sense of 122 lines of code, very nimble. I love that for sure. I was a bit surprised, like really that's all? It looked bigger. It was bigger in my head, let's say. And we create a parser and then we parse. So that looks a bit like a function call. Like this, like I really just share my intuition here, right? I didn't think about that and could be wrong, like whatever. But like if you instantiate something and then you call one function, then you can also just call the function, because state is only good if you use it over multiple function calls that are related to that state, but that's not happening here.
Well, that's what's happening internally in the parser. So I started with one function basically, but I had this iterator. So this is how it's basically parsing. It's just iterating through all the bytes. And instead of passing this iterator around between different functions, I just thought I'd make a struct and then have it use the same data basically. It seemed easier to me than just passing it around into different functions.
Okay, makes sense. Also, it's private to the parser, to the parse module. So I'd even, even though this is my intuition that this could be a function, and it could be, it's small still, right? So, but still, you really have it nicely separated here, nicely compartmentalized, I think. So it's easier to have this input on self input. Makes sense. I guess to make it a bit easier on me,
you wouldn't need the variable, I guess, right? So
I could do it like this, and now it looks. Yeah. Oh, now I'm happy, and now I think this really wants to be the way it is. Now you have the benefit of having easy access to your state, which allows you to nicely write these small little functions here. And yeah, that's awesome, huh? I mean, you parse the magic signature and you pass a pass and nothing can fail, even though we know it can. You mentioned that, and I already peeked at the code, so I know that there's this one panic that wants to be removed, but it's this looks great. And that really, like from a style perspective, it's top down, and it tells me, there's this magic signature that is very magic. And I also read this somewhere in the source code, like this magic stuff, and I really didn't know what that is supposed to be, and still don't. And that's what magic is supposed to be, right? If you're not a sorcerer.
That's just what they call it.
So we might find a better name once we really know what this is. But until then, it's magic.
Magic.
And then you pass the path. So probably that's going to change once there is some potential for failing. Thank you very much.
Yeah, exactly.
10 minutes left.
Mm-hmm.
Okay, So first it parses the signature. That's the top stuff we've seen. This is why it comes first.
Exactly, yeah.
And yeah, now to look at the input again. So it's basically iterating over bytes. Byte by byte, it consumes the input. That's an interesting choice because this is really an interesting choice and something that I don't think I ever did, because once you have a slice, you have such a, you have everything in memory, you can random access, you can do what you want. It's like sometimes you want an iterator and you can just make one on the fly. Like get an iterator over like whatever you have there, and then you work with it a bit, and then you might count how much you consumed, and then you splice it or strip it or whatever you do with the slice, and then you can consume it that way, kind of on a slice basis, on a working with a slice, which also allows you to consume byte by byte if you want to, creating kind of a new slice each time with a byte less. And performance wise, you don't even think about it because all that gets totally optimized away.
Right, that's what I wasn't so sure actually. Like if this is actually performant enough, like if you create or keep creating iterators of the same data, basically.
Yeah, and there, I mentioned the word performance, but I didn't mean to make it, like it matters, because it's not. It doesn't. Like as long as you don't allocate, performance does not matter. Like if it could be a few cycles faster if you did X over Y, doesn't matter, because it's too fast anyway to count. So what matters really, and this is what I want to stress, is that the code is readable and is the most obvious code that you can write in Rust and the most convenient code. And if this feels convenient to you, and I didn't look at anything further yet, then it's the right thing to do. And that's all I want to say about that. So no issues with that. If it feels good and you like what you had, great. Then let's do that. But I found...
No, but this is what I'm curious to hear, because for some, like, this is just how I thought about the problem. And for me, just, yeah, this is how my head spat out the code, basically. But yeah, let's see if this is actually something that works, or if this can be improved, which I'm sure it can be.
Yeah.
But yeah, I'm curious.
Well, you got that far with this. This means it worked well, and you didn't need more, and you just need to peak one, and that's it. And that's that works and keeps working, fine, then that's probably how it's going to be. And if not, you can change it to something else, and then you just have these iterators on the fly, which works just as fine, probably. There's usually some overhead too, because iterators, you have to count how much you consume then, and that's usually annoying, so that you get back, so that you can get the slice back later.
Exactly.
So yeah, I usually tend to just use split a lot and find, and like really kind of stupid find, split, blah, 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 blah. And that's how I consume these things. And then you do more at a time and don't have to do this single character thing. But anyway, that said, let's continue and take a look. Okay, so what's next? This looks like, I just try to read it now that I know a little bit about the syntax. So this is a magic signature start, and there comes the magic signature. That's nice. And if there is no such thing, we don't consume, we just continue. Cool. So here it seems like a perfect application of peeking, but also you could just read the first byte of a slice. Okay, let's see. Now you consume this one, and get some mutable signature, and then we check the next one. So how much? Yeah, 5 minutes left. All right, now after the virtual cut and the zoom extension, we're back here in the magic signature. Okay, so we parse a second colon, or we see a second colon, and There's this typical pattern, huh? First we have to peek and then we have to consume.
Yes, that is something I kind of dislike because I started with consuming directly. But of course, there's this one crossover where you have to break out of the magic signature, and then that one last character is still consumed. So you have to use the peek and do it very explicit here.
Yeah, I mean, this is self-input. If you can, of course, assign a variable or something, then it's just it next. And that might help a little bit ultimately. Yeah, the lines are there. And with slice syntax, yeah, just easier to look at things. But then it would be mostly like, yeah, some counter plus plus or plus equals 1. So I think it would be somewhat similar. Okay, so the signature is not empty. Then we can just skip to the next one. Then probably the path is happening and we break out of it. But if the signature then is empty, we just... Yeah, that's an interesting question. So now the signature would be empty, right?
Yes, and that kind of means that it hasn't, like this would be the first or the second or third colon when there hasn't been a signature yet. And as soon as there is a signature and we find another colon, it should be the closing one, basically. That is the thought behind
it. So is it like this would literally mean the signature is not, I mean, you just explained it, but maybe I try to paraphrase. So the signature is now empty and we have seen a second colon, but there might have been something in between, but that didn't lead to the signature being filled because maybe it was an invalid or unknown signature or something. Or I don't know, maybe.
Maybe it's easier to look at examples in the test case.
Oh, you know what? You're right. I mean, we have tests, right? So what I'm thinking is true. Like, you see how I'm thinking about this now, like what does it actually try to, what is it actually saying? So what if we'd say that in the signature, like in any case, it's just some refactoring. In any case, we do this. And then if the signature is, if the signature is not empty, we have done something, so we break out. And isn't that the same thing?
That is the same thing, true. I think I even started with this. And then I thought, yeah, maybe it's nicer to write it with this other, like quicker if syntax maybe. But
quicker in the sense of
I don't know.
Faster?
I don't know. I feel like it's maybe a bit easier to read. I'm not sure because you have it kind of each case for its own basically. But yeah, this is really a style question, I guess.
Yeah, but that's the thing. I understand perfectly what you mean, and I have the same intuition about match, and match can be super cool. It's more like, you know, it causes me to think more because now I have to think of the case with the if statement and the one without. And this reads more, this is more clear to me. It's always, so we consume it. Whenever we see a colon, we consume it. And then if we have something in the signature, we break out of this this loop. There's no outer loop. Okay, this is the loop.
Exactly.
This makes it clear, no questions asked, and I like that more for that reason. And
yeah, agreed.
The magic is the shortcut things apparently. Okay, we have a colon and then.
Not only.
Okay, getting there. And then we have a slash, colon, slash. And then we have top. Okay. Then we have the negation. And we have an open, the parentheses open. And then we do the magic keyword parsing. And that seems to be consuming at least the closing parenthesis. And if it's nothing else we know, then we don't consume the character and just continue. Ha! That's a good one here. I like that.
I'm gonna be curious what this is gonna look like.
So what I want is then some.
Yes. I had this, and then it told me that it's part of the what did I call it? Like it's not fully tested in Rust, or it's still unstable.
Unstable,
like
yeah. This is what I said. This is what I want. I want then some, but only then I have. There's a ton of places where you want then some, but we have to use then with the callback, and that's just how it is.
Okay.
That can be refactored later. And I also want a negative case, like if it's, the opposite, so you don't have to do the parentheses thing and some negation. I want to say, no, maybe I don't know what I want, but anyway, that's okay. Then, yeah, that's that. So let's run the test, and that should just be refactoring, nothing else, and that works. So signature not is empty, then we take the signature. So yeah. And there's no other way to write it. I would love to not have the negation here. So is there some, is some, maybe there is signature is, no, there's only is all. This doesn't work, it's empty. Okay, fine. There could be some not equals, but yeah, we can do an empty one, not equals signature empty. But is that nicer? I don't think so. I mean, then you put the not then you get rid of this one. You do get rid of that, but you have then you have it
in the middle.
Yeah. Yeah, but you still need the parentheses. So anyway, I think that's good enough. Then we parse the magic keywords, and it happens to be just underneath the function we've just currently been looking at. So that's wonderful. Convenient. Okay, so there's a bunch of vectors here now we allocate. And I wonder why, because we output something that is definitely not a vector. It's just some bit flags. So there should be, intuition says should be no need to allocate here.
Yeah, this is probably very much a shortcoming of this iteration method.
Ha!
Because yeah, actually thinking about it, this could be easily, or could be much easier if you just split.
Yeah, right. Because you have the data, right? And now you pretend you have a stream, but you actually you have more than a stream. So this is the reason for you to use the slice. Because this, I mean, again, performance doesn't really matter. You have one allocation, another one, and then for each of these keywords that you can write another allocation. There's like a stack of strings or list of strings and some additional buffer. So yeah, that wants to be refactored, I think, so that it's not like this. And again, it's not really a performance question, but more like a style question. Like GitOxide cares about allocations, and okay, let's not jump the gun here. Like if the code is super simple and it couldn't be easier and it's really readable, I'd say, okay, fine. Readable code is preferred, but I have a feeling that maybe that's not needed. Okay. Then we check. So we have a closing bracket. This is kind of a temporary buffer, right? This one.
The keywords is a temporary buffer, yeah. And then the buffer is basically being reused and it fills up into the next comma and then drains itself into the keyword. So it's basically a mapping from characters into whole words. And these you can then compare against, or just match into the magic signature enum, essentially.
Yeah. So we keep, wait, that this is already a vec-u8, right? And then you push it onto keywords which once vec-u8s. So why not just push the buff? You want to say because of
because I'm reusing it essentially, right? I mean,
but look
so
at this.
Of making potentially.
Look at this. You're reusing it, and you want to say ownership, but then you pass ownership. This is consuming. This is consuming the value. And now I wanted to see a borrow check error or a compile error, but it's not happening because the break is here. So it knows that we are not going to use the buffer afterwards, so we can consume it. So that's pretty cool. Honestly, the Rust borrow checker is really, really powerful, especially in loops. I'm always surprised how great it is. So I was expecting actually a compiler error, but the break makes this unnecessary. Okay, so now Mr. Smartypants, me, says, oh, I found an issue and I do this here too, and now there's all the red squiggles and it's now it's having the issue here. Huh? So if you have a comma, we take what was there before. So here, spaces are an error, right? Okay. This is where we would have to do something about that. Okay, fine, that's a to-do. And here, svmem take is what you want.
Yes.
Because what you've been doing there is kind of like even more allocations with the drain.
Yeah, okay.
And then you build you take from a vector, you build a new vector, which then has to allocate multiple times, potentially. I think it's implemented so that it knows the size because the input iterator has an exact size. So anyway, another allocation there. And I don't know if ultimately, probably you only have one more allocation that is needed or something, but it also looks better that way.
Yeah, this was essentially what I was looking for, like just swapping the buffer from the data from the one buffer into the other one. But I couldn't find the best method, and the drain just popped out, so I thought I'd try that.
Yeah, and that's exactly the thing. That's right. I mean, take is like a swap with default, and this is why take works. Take out what's in here and replace it with default, and that's why we have an empty buffer afterwards. That's why the test is still working. Okay, and otherwise we keep this letter and keep it for later. And you know what? I do like this. I do like it because it seems simple. You know, I really like. Oh, it's okay. I think I don't like that it's keeping references to bytes. I mean, you know, like this stuff you gotta copy. Like now these vectors, they hold more data than they need, 8 bytes for 1 byte. And then you need an indirection. So
that makes sense.
That's something like, no. Let's see. Let's see if we can just make it into what it has to be. Just derefs the borrow and gets us a copy of the byte. And now this still works. Good. And you know, I'd even keep it that way, honestly. Like, we are still refactoring, we're still not done, but these allocations I don't mind, because again, Pathspecs, you don't even have them in a file where there could be thousands of lines. No, you have them on the command line, or you know, it's very limited. So yeah, I have these allocations, makes the code not less readable. I like it, so let's keep it. But let's see, let's just experiment. One more idea I have. Yeah, I'm over optimizing. Okay. Actually, this doesn't need to be mud then. Okay. So now we have a buff.
Okay.
And we say if the buffer is empty, then we pop. And if the buffer is not empty, then we push a new buffer on top, because we are already looking at the buffer, the last one. We just stop using this. So push a new buffer and replace. Now we want to make it mutable because we have to reassign this. And now we have a new buff here, which is keywords last mud. Okay. And then we have a buff that we can push on, and everything should just be fine. And it is, and we've got one thing less. Now the question is it better? I leave that for you to decide, to be honest. It's more code and it's maybe more complicated to think about it, but it's one less. Is it one less allocation even? I don't know. I don't think so.
I was just thinking about.
I don't think so.
Because you still make that initial vector there, right? Which was just then directly assigned.
Yeah. Like, we pre-initialize this vector, so it has a size of, yeah, I mean, if you want to optimize allocations, but I don't think it matters. Yeah, I'd say it doesn't matter. It makes it more complicated. So it's just me. I only use the
not liking macros.
I do. I just use them, and I actually have something to initialize them with. I don't use them empty, but it's more to type here, huh? And it's kind of a bit more noise. But then again, you wouldn't type this, and
okay.
You wouldn't type this either. So. Speaking of, is there some other, no, typing going on that isn't needed? No. And now it's, I think, prettier. Okay. Then moving on. Now we initialize this. So wait, there's this magic signature. Ah, yeah, right. So we parse the keywords themselves. It's also just a signature, and we just OR this here, and that's how this works. Okay. So now for each keyword, oh yeah, this is not needed anymore because these bytes are now owned.
Exactly. A lot easier.
And oh yeah, so this whole thing goes away. And then you make a string out of it. And that gives you a cow. Or you just match on binary strings. Because these are then, you know, this is essentially ASCII encoding. And also Git assumes ASCII encoding as the baseline. And UTF-8 happens to be ASCII compatible. So then you only have to deal with this. This invalid signature is probably also to do here, huh? Because now you can actually panic kick.
Yeah, actually, I don't know at the moment if it accepts invalid signatures or if it just
Yeah. I mean, you can never panic for sure.
Yeah, exactly. This has to be an error in any case.
This has to be an error. You can, you know, sure, you have to convert this into a string. Use bstring for that. Like, that's what it's there for. Don't use string UTF-8 lossy. Bstring is nicer for this. And since we are going to change this anyway, just remove that and don't deal with it at all. And then look at this repetition here. Probably means you want to write signature or equals. Yes, you want to write that. And because we...
Oh, okay, yes, makes sense.
And because we do want to use, I mean, you know, and I see this when the enum variants are smaller, shorter than the actual enum, and it just, then just import that here.
Mm-hmm.
It should highlight this. I don't know why it doesn't do it. Is there something wrong? Ah, yeah. Huh? What? Oh. Right. It's, sorry, it's not a, never mind. I took it for an enum, but it's not. Yeah, it's a bit flag.
Yeah, I mean, this was a question for me as well. Like, if you can do this sort of stuff with an enum as well, but I'm guessing that's exactly why the bit flags thing exists, right? Because you probably can't like bitwise them together.
And these values are part of the struct apparently, and not in a module, and this is why you can't import it like this. Never mind then. Okay, a little bit nicer. And yeah, I think that's okay. Of course, you can fold this if you want to, so that you don't have to write the for loop and just, you know, how do you call it? Reduce, right? That's a reduce operation essentially. But that doesn't usually make it more readable to my mind. And the benefit of reduce would then be that you had this as a return value, right? You wouldn't have to write this separately.
Right.
But since soon you're going to have some error here, we wouldn't want to put stuff into a closure. That makes it harder again. And I think this is a good basis for future error handling. And yeah, okay, fine then. Have some white space here. I'm always like, okay, fine. It's okay. And then we have the path. Oh yeah, right. Now we have to clone again. Consume the... Can you just do cloned or copied? Okay. And this by ref, you know, because copied wants to consume the iterator, it doesn't work because we are behind a mutable ref here and we can't consume stuff. But it's a nice hint for us because we can ask ourselves, do we want, like, is this parser useful for anybody? Is there, and it's empty, it's definitely empty after this. And I'd be totally fine saying, let's just consume it. That's the last thing you do. And then this should work.
True.
And then we do that, I guess. And now, you know, it's kind of a little bit of a, I don't want to call it crutch. That sounds so negative. It's more like now it's temporary, so to say. It's there, it's useful, and once it's done being useful, it's not there anymore. And
yeah.
I like that. And this kind of reflects how you use it as well. And now you can't misuse it or accidentally keep using it, even though it's empty and not usable anymore. And this reflects that property in the API. And, you know, there's a call order here, and you gotta do it right. And that's how it's meant to be, and only like this. And that's all. I think the next thing could be error handling. And then it can totally stay the way it is with the allocations that are there. Because I don't think it will get nicer when you use slice-based syntax. You will use kind of a functional approach. You will probably have a little method that say, you know, it will have little method or functions, sorry, that take a slice and produce slices and do it like this. And then where it matters, you don't have to allocate. So you can be completely allocation free for sure. But here we allocate anyway. It's not worth it, I think. So, and the code is pretty nice the way it is. I really feel like the self-input, like the peaking, okay. But then again, you know, why not try that? Let's replace all of this and make it. And then this is a not it. And then it's a bit less wordy.
Other.
Oh yeah, right. We want to do this. Yeah, right. Haha.
Oh, I see.
Makes sense. We can't keep it here. We would have to drop it and then recreate it afterwards. So we can't do that. No. Can't do it. Can't rename. Unless you want to dance around things, and I feel that would hurt the code's readability. And this is where you say, you know, you bundle data together, even though it doesn't want to be there. Like this iterator doesn't actually want to be owned by self. So I think having a pure functional approach here wouldn't hurt. You could say that this type signature isn't pretty. 10 minutes. Nope. Type signature isn't pretty. Just make a type. Byte iter. Peakable byte iter or whatever. Something.
Yeah, that makes sense.
Like this. And then you can just use this in your function signatures. I mean, even though it's now much better than before, also with the consuming thing here, it's a mere gimmick, and it prevents you from making this even more readable. You could just call it and have a little tiny name there. I like concise code that everybody knows that it is the iterator because you're looking at this longer, so to say. We're not in Java land where you have to call everything peakable byte iterator dot next character, please, thank you, and have a good day, sir. No. So I would go for the pure functional one as the next refactoring. But we are not having enough time to do that here, and also no need. It's a nice exercise. Plus the error handling, I'd say.
Error handling, and like I said, parsing isn't fully working yet because there's this one little attribute magic word, which then actually carries the actual attribute, and that is not being parsed yet.
So error handling, no panics, pure functional. You don't have to do this, by the way. I just say it would make it even better.
I'll give it a try for sure.
Okay, then I put it here. It's not a dictatorship. But if you don't do it, I don't merge.
An opportunity to learn, let's say it that way.
Yeah, it's a fun little refactoring. Really, if it would be a ton of work, I wouldn't ask for it. But this, I think, can be can be good. So, and we should all be real fast in refactoring, right? So I think it's a good thing to do. And the other thing you mentioned was what again?
Oh, the attributes still have to be parsed. So the magic keyword is parsed, but not the actual attribute.
Not the actual attribute.
Yeah, there's the syntax, I think, where you write attr and then a colon and then the attribute that you want to filter for. And yeah, that's being ignored at the moment.
Oh yeah, right. This is tying into Git attributes then, which is crazy powerful if you know how to use it, I guess. But yeah. There is attribute parsing as well, by the way. You can use a Git attribute parser. Git attributes lib, we have that. And there you should be able to parse stuff.
Yeah, cool.
It's public.
I have to take a look at what exactly is required there, but that might come in useful, yeah.
Yeah, it doesn't seem to be public enough to parse. It wants to parse lines, and the line includes the attribute. The line includes the pattern, which you don't want. You just want attributes. But here is definitely an attribute parser. And you just have to make it public enough to be able to get there. I think it's definitely there and it's separate enough to work. Here, where's the attribute parser? Yeah, this one.
Yeah, okay.
Here, parse adder. So here's the attribute parser, but you have to refactor it a bit to make it available to the outside world. And I would love it if you could use this one, because why duplicate the code?
Absolutely, yeah.
But then again, also it's super easy to parse these things, but then again, it's...
Yeah, I mean, maybe the parsing is also then, in the, like this attribute parsing is in the end then part of the matching, I'm not sure. But so the parser basically just gives you the part of the string that represents the attributes, and then, yeah, not sure what's better here.
Yeah.
That probably would be done in the parser.
Probably it's part of the data set you get, and you want to have access to the attributes. Yeah, it's also pulling in another crate then, which is this one big? I don't think it is. Yeah, 1,000 lines of code you pull in just for this little parser. I mean, it's okay, we don't optimize to that extent. I think rather save the time to implement a test, a parser for attributes, because this one is tested and it works and you can just use it. So yeah, use this and make it work, and integrate that. And you see these lines. Anyway, you will see how this works when you get to it. I think you can leverage it. Okay. Yeah, right. And this probably is something. Okay, something like that. Cool. Then, now I should be able to push this. Git push head pathspec. And that concludes our review. Yeah, there is now git lfs. So you have to skip the hooks that try to do LFS stuff, and then you can push and make it all work. Yeah, that is our today's sessions, and that's how I like to do reviews. That's really cool.
Yeah, that's awesome. That was great, very helpful, and I'll have some updates for you next week. Yeah, we'll see how far I get.
Yeah, I mean, it seems to be going pretty well. So I wouldn't be surprised if the whole parsing would then be done, even though like having Git approved error handling, or this baseline, that's kind of a development task all on its own, but also a basic skill that is super useful, I guess. And I'm looking forward to that too. Cool. So thanks a lot, and see you next time. Bye bye.
Thank you very much. Bye bye.